Volume management. In this nugget, we'll be looking at volume management, and specifically, we'll pick up right where we left off in our last nugget, and we'll start with a disk conversion. Our last nugget, we looked at converting basic to dynamic. We'll start with looking at how to convert back from dynamic now to basic. And then we'll also look at creating the volumes, and this is particularly with dynamic disks, and there are several different types of volumes you can create, 5 in fact. A couple of those are RAID volumes, that's a RAID 1 and a RAID 5 volume. There's also a RAID 0 volume, but it doesn't have any recoverability. But we will talk about how to recover failed volumes if you have, for example, a bad disk in a RAID 5 or a RAID 1 volume. Then we'll look at moving the disks, especially if you have a computer that's blown up on you or has a problem and you need to move those disks to another server. We'll talk about how to properly import them because they will be designated as foreign disks in a new computer. And then we'll look at various disk utilities. These will be things such as defragmenters, check disk utilities, as well as various command line utilities that you might find are new to you in Windows Server 2003. And then we'll look at quotas so that we can limit the amount of disk space given users can use on the hard drive. Well, now let's go ahead and talk about deleting and reverting and all that kind of stuff. For example, with these basic disks, if I wanted to delete any of this, you just simply right-click and delete whatever you want. Delete logical drive in this case. Going to lose all the data, of course. I'll just say yes. Then I can do it again here. And then once I've deleted both those logical disks, then I can delete the partition, which is the extended partition as well. And then I can do the same thing here for the primary partition. So I'll just delete the partition, and away it goes. Now, for the dynamic disk, what if I wanted to revert that back to a basic disk? Say, oh, wait a minute, we made a mistake. This is supposed to be a basic disk. Can I right-click and choose Convert to Basic Disk? No. I mean, it's grayed out. You can kind of see it there, or dimmed, as Microsoft calls it. So no matter how many times I click it, nothing's going to happen. So what I'll need to do here is very simple. Microsoft gives us a very easy and intuitive way to convert this back to a basic disk. You know what it's called? Delete everything. That's right. You take this disk, you right-click on it, you delete the volume. Since it's an extended volume, it's going to delete both volumes at one time. I'll click on yes, and there you go. So easy situation. You want to go back to basic, kill everything, and then now you can right-click on this and choose Convert to Basic Disk. Now, of course, you can also change drive letters, and I can't show you on anything that I deleted here because I've already deleted it. But I'll just show you on this CD-ROM, for example, which I'll often give a drive letter in the middle of the alphabet, like drive M or something. You simply right-click on any drive like a CD-ROM or removable storage or partition or volume, like the kinds I just deleted. Then you choose Change Drive Letter and Paths, and then you just click on Change here and specify some other letter here and click OK. It'll tell you that some programs might not work anymore because they might have originally pointed to that drive D, and I'll have to make sure that I'm confirming that I want to do this. I'll go ahead and click on yes because I know that wouldn't affect anything in my case. Now then, offline here, I went ahead and made all these disks dynamic. Well, what do I mean, by the way, when I say offline? That means I paused recording, did something behind your back while you weren't looking, and then I started recording again. So what I've done is made these dynamic because I want to show you some of the volumes that I was not able to show you with a single dynamic disk before. So we'll right-click here and choose New Volume again, and this time we'll choose a spanned volume, which allows us to select from a number of disks. Now I can choose the same amount of disk space on each one of these disks if I want. Let's say, 200 megabytes off of each one, or I can make that different if I want. 200 there, 300 there if I want. It's more intuitive and easier to track your utilization, your disk utilization, if you make them all the same. But they don't have to all be the same. And we'll go ahead and click on Next here. And again, we'll assign a drive letter. Just let that go. And we'll just call this a spanned volume. And we'll perform a quick format. And then we'll see that once it's finished, it makes a purplish color here for all of the members of the spanned volume. Now what will happen is, as soon as the disk 1 fills up its 200 megabytes, it spills over to disk 2 and then to disk 3, as we discussed in our spanned volume discussion earlier. Now, with the spanned volume, I can still also extend that if I want. So I'll just right-click here, choose Extend Volume, and I would choose the same steps as you saw me do before. So you can indeed extend a spanned volume if you like as well. Incidentally, let me also point out that in order to do any of this, such as initializing disks, converting disks from basic to dynamic, creating volumes, all that kind of thing, I have to be a backup administrator or an administrator, a member of the local administrators group on the computer. The only thing is, a backup operator is not able to format disks, but they're able to do everything else I've shown you. Now, any of the volume types that are available with a dynamic disk, any of the 5 types, you can mount to an empty folder like you saw me do earlier. And I can also, again, do that with a primary partition or a logical drive. So you can really pretty much mount anything to an empty folder as long as that empty folder is on an NTFS partition or volume. Now let's go ahead and take a look at another thing that I could do here. Let's say that right now this is mapped to drive E and I realized that was a mistake. I needed to map that to a folder on drive C. So I could just change drive letters and paths, and what I would have to do here first is to remove drive E. I can't just change this because if I want to mount it to an empty folder, it doesn't give me that option yet, so I have to remove it, click yes. Then I have to come back into it, right-click again, change drive letters and paths, add. Now this time it gives me the option to browse for a location here, and I'll just call this new folder, extend this, for example. And then once I've done that, I'll click OK, OK, and now it's going to map to or be a mounted volume for that particular folder on drive C. Then once again offline here, I've deleted the volume here, so I'm going to create another volume, and this time we're going to create a new volume of the striped volume type, and we'll go ahead and click on next. Now, contrary to the spanned type, when I add these disks in here, which can be anywhere from 2 to 32 disks, when I specify a size down here in megabytes, it will be the same across all three, whereas a span disk, it can be different sizes on different disks up to their total maximum storage availability. So let's say I made this, 500 right here, then you see that it changes to 500 on each one of these for a total size of 1,500 megabytes. And then we'll click on next, and again, this is mostly the same kind of stuff. We'll just next, finish through all this. Again, you can mount this as well if you want, and we'll just call this striped, and we'll quickly format this. And again, we'll see that once it's finished, it has gone ahead and created that volume for us, that striped volume. Now, the other thing we could do here, if I go ahead and delete these, is to create another kind of a volume, and let's go ahead and take a look at that. Let's create another volume, and let's create, this time, a mirrored volume. Now, a mirrored volume only uses 2 disks, so one of these disks will not be part of the discussion here. We'll simply click Add there, and notice that it even grays this out after I've added it. Also, with the mirrored volume, we have to create the same size again, so if I choose 500, then notice that it automatically makes both of these 500 as well. Then we just simply click Next, and again, we can mount that to an empty folder if we want. We'll just go ahead and call this mirror in this case, and again, we'll quickly format it, and Next and Finish. And then we see now that we have a mirror on both of these disks, meaning that data is being written, the exact same data is being written to each of these disks simultaneously. Notice that it's also resyncing, and that's not really too drastic of a function right now unless we were trying to repair a broken mirror, in which case when it resyncs it makes sure that the data on one disk is exactly the same as the data on another disk. Now then, a couple of other things we can do with a mirror is to right-click on one of these members, doesn't matter which one, and we can break the mirrored volume. This means that both mirrored volumes will continue to have the same data on them, but any new data that is written is no longer written to both of them simultaneously. So we lose our redundancy from this point on. We can also remove the mirror, and if I select that option, I could choose to remove redundancy from one of these volumes. This might be useful if, for example, I'm getting some disk errors on disk 2, and I want to take it out and wait for a replacement disk, and then I'll put the disk back in. While it's out, disk 1 will simply be a simple volume. So let's go ahead and take disk 2 out by removing the mirror. If you want to remove it, yes. After I've removed it, then I would take out this disk, and then now let's cut ahead and say that we've now replaced it. Well, after I replace disk 2, and it's a healthy disk, how do I make this mirrored again? By simply right-clicking on a simple volume, and you can do this with any simple volume, and click on Add Mirror. And then you simply select the disk again, disk 2 there, add mirror, and at this point it will resync with disk 2, gives you a little icon on disk 2 here in the meantime, a little yellow symbol that you'll see here shortly, there it is. And that tells us that everything's not quite right, it's a cautionary statement, but that's okay because all we have to do is to wait for this to resync, at which point that little icon goes away. And so now that they've resynced successfully, that icon goes away as stated. Now let's go ahead and break the mirrored volume just for the practice of doing that as well. If we break the mirrored volume, again, our data will no longer be fault tolerant because there's no redundancy anymore. We'll go ahead and click on yes. And at that point, we'll see what happens here is that these are now both simple volumes. They're just simple volumes of the same data. Notice that they also get separate drive letters now. Now then, if I decide I want to do mirroring again, at that point, I'm pretty well finished. I can't do mirroring again with this. These are just independent, simple volumes. The only way really to fix that would be to delete one of these, so I could right-click here, choose Delete Volume, click Yes, and then go back to this, go ahead and add mirror by right-clicking here again, and choosing Add Mirror, and then selecting the disk up above there at disk 1, add mirror again, and then we get our mirror generated back again, it resyncs again, and after it's done at 100% here, we'll be back in business again for mirroring. Alright, now then, offline, I went ahead and actually physically removed disk 2, which was the SCSI disk 2 that we had for the other part of this mirrored volume. Then this what that used to be disk 3 was renumbered to disk 2, so don't confuse this with the mirrored volume. And then it tells us that the one that we did have involved here, that was the other part of the mirror, is now missing. And this could be the case if the drive went bad or it was physically absent, like I've done here. Now in this case, since it's failed redundancy, we would do something similar to what we've done before. We would simply right-click here and choose Remove Mirror. And then it's pretty obvious which one we want to get rid of here, the missing one. So we'll choose Remove Mirror from that one. Are you sure you want to remove the mirror? Click Yes. And now we're ready to get back in business. We've still got another dynamic disk here. We could just right-click here again, choose Add Mirror, and then re-mirror this particular volume, and we're back in business. Now here I've switched over to the event log, which in the interface is called the event viewer, but we just call it the event log, and it gives us application security and system event logs. There are also other kinds of event logs that will appear depending on the kind of system it is. For example, if it's a domain controller or if it has DNS running on it, then it has additional kinds of event logs in here. The reason why I'm here, though, is because I want to show you one event log that you can look for if you do have a problem with a disk that has failed redundancy like our mirrored volume that we just looked at. Here we have a warning for DM boot. If we double click on its event ID 2, and it tells us that the volume spanvol2 drive E started in failed redundancy mode, of course, because I removed the hard drive physically. And I'll just point this out to you so you know what to look for in the event log to check to see whether or not a disk has failed redundancy. Now here I've gone back to just unallocated space so that I can show you another kind of a redundant volume, and that would be a RAID 5 volume. So we right-click and choose New Volume here, and again Next, and this is the RAID 5 volume, which requires a minimum of 3 dynamic disks and up to 32 dynamic disks. Now here we'll just go ahead and add the additional members. Notice we can't even click Next until we have at least 3 in there, so we'll click Next again. And again, with this, as with the mirrored volume, whatever I enter in here will designate the amount of disk space on each drive that is going to be used for the redundant volume. So let's do 500 megabytes here again, and then we'll go ahead and click on Next. Once we've done that, we see that the following drive letter is going to be assigned. We'll just go ahead and let that go. Again, we can mount it to an empty NTFS folder if we want to. And then we'll just call this one a RAID 5. And we'll go ahead and perform a quick format. Now let's go ahead and click on Finish, and it's going to go ahead and create the volume, and we'll be ready to go. Now here we see that the RAID 5 volume is complete. Let's go ahead and take a look at some other considerations, especially as we compare whether or not you want to use RAID 5 with RAID 1. What if performance is the issue? Well, if you're looking for fast read performance, RAID 5 is probably your solution, because the more disks you add to this, the more disk performance you get. And remember, you can go up to 32. Whereas with a RAID 1 or mirroring, you get only 2 disks there. So with RAID 5, you can get very, very fast read performance. One other reason for that is because there's no parity calculation in reading the data. However, in terms of write performance, you're probably going to get better performance out of a RAID 1 mirror because there's no parity calculation involved in that, and with duplexing, you're sending the data stream through 2 separate data controllers or SCSI controllers. With RAID 5, its write performance is usually slower because it has the overhead of the processor utilization that's required to make that parity checksum on one of these disks. And remember, the parity will be scattered evenly across all 3 of these disks. That brings up another issue called overhead in terms of the disk utilization. Here, I'm occupying 500 megabytes times 3 for a total of 1.5 gigabytes. However, how much actual useful storage do I have? 1 gigabyte, because 1/3 of this total storage is used for that parity checksum. So that's my overhead. Now if I add another disk, and I had disk 4, then I would have 1/4 required for my parity checksum. If I had 5 disks, it's 1/5, and so on, all the way up to 1/32 if I had 32 disks, at which point I have a very low overhead. Now with mirroring, it's more expensive in that sense, because I have a 50% overhead. So that if I had 2 disks, 2 mirrors, for example, that were 1 gigabyte each, 1 gigabyte here and 1 gigabyte here on a mirror, that's a total of 2 gigabytes that I'm actually using for the total disk space, but I'm only getting 1 gigabyte of useful data between the 2. Now again offline here with this RAID 5 volume, I've removed one of the disks, which of course says it's missing here. Now what happens to my existing data that's still here? Well, it says failed redundancy, but my users can still read from and write to this disk. or this volume. What happens with the reads is that it will reconstruct the data using parity information from either or both of these disks to rebuild the information. That means that now you got processor utilization for the reads, which we don't normally have otherwise. For the writes, it's just backwards. Now for the writes, there is no parity calculation because there's no third disk with which we can calculate the parity. So these will just be normal writes to both of these volumes at that point. And in fact, we can even look at this RAID 5E drive, double click on this item here, just enter in any old text here and save it, and it saves just fine because we still have the volume actually available. We just don't have any redundancy anymore. Now, of course, if we lose another one of these disks, then we're done, and it's time to get out the backup tapes. Now, what happens is if this disk is simply missing because the power cable came loose or the SCSI cable came loose or it just wasn't well connected, then what would happen is once you reconnect it, then all you have to do is to right-click here, and then you just choose Reactivate Volume. Now, it won't do me any good now because I actually physically removed that SCSI disk. But like I said, if you can bring the original disk back in, that's really all you have to do. Now, otherwise, if this disk was just smoking and went bad and we had to throw it away and get a replacement, then what we'd have to do is to, again, reinitialize that disk when we started the Logical Disk Manager by opening the Disk Management console here. And then once we bring it in, we convert it to dynamic, and at that point, we would be able to reconstruct the RAID 5 data. And you would do that simply by right-clicking on it and choosing Repair Volume. At that point, it's pretty much the same as the mirrored volumes. It starts to regenerate the data, and then you're back in business. Now then, returning to disk management after having offline put on another SCSI disk to replace the missing one that we saw earlier, we see that it's going to, again, give me the Initialize and Convert Disk Wizard. We'll go ahead and click next to Initialize Disk 3, my new Disk 3, and we'll go ahead and convert it here as well. Might as well because we're going to need to use it to complete my redundancy for my RAID 5 volume. And from this point, all I'm going to do is once it's available, I'm going to go ahead and right-click here, and I'm just going to choose Repair Volume. By clicking Repair Volume, it selects Disk 3. If there are other disks, I can choose which one I want to use to repair the volume. Click OK. Then it resyncs all the data, and once it reaches 100%, again, like I said, we'll be back in business. Now then, you might also run into another situation in which you have a server that's running and it has some disks in it, some dynamic disks, for example, and the disks and the data are just fine, but something else goes wrong with that server. The power supply goes out, something burns up in there, or something like that. Someone spills a Coke on it. Whatever. So when that server goes down, you still need to get those disks out of there and put them in another computer that is still running and that can provide the data to the clients on the network. Well, with Windows Server 2003 and dynamic disks, this can be done in just a matter of minutes. You can also do it, by the way, with basic disks. Really, the only difference is with dynamic disks, it will retain its drive letters that it originally had on its original computer when you move them to the destination computer. However, with basic disks, when you move the computer disks from the source computer to the destination, it just accepts the next available drive letter. So that's a slight convenience that we have with dynamic disks. And in this case, on DC Nugget 3, I've taken 4 disks, SCSI disks, that had been in another computer named DC Nugget 4. Now, when I bring them in here, it marks them as foreign disks. How does it know that they're foreign disks, and what does that mean? Well, if they were dynamic disks in a previous computer, then it will mark them as foreign, and it identifies them that way because it sees that they have been initialized. It's just that it was not this computer that initialized them. If it was a basic disk, well, they would just show up, and they would probably not have a drive letter. You'll see a volume over here for it, and or a partition. You'll have to right-click the partition and assign a drive letter to it. In this case, all we have to do is to right-click on the foreign disk and choose Import Foreign Disks. Then we see that it gives us a foreign disk group, and it clumps all these disks together in one group. Well, why does it do that? Because it sees that they all came from the same original computer. If we were bringing in a couple of sets of disks from 2 different computers, then we would have another checkbox for another foreign disk group here, and you can click on disks to see exactly which disks it identifies as the foreign disks. And we'll click OK here. And then we see here a little warning, ooh, the data is incomplete. Don't worry about that. That's just because it has not resynced yet on this computer. Once we see that it's resynced, we'll see that everything is healthy and everything will be all right. We'll also get another alarming message, by the way, when we click OK here, because we'll see that, oh, by the way, there's also just a plain simple volume there as well. We'll also see another alarming message when we click OK here, and it says, some of the volumes you're importing will lose data because you've not moved all the disks to this system. You sure you want to continue? Don't worry too much about that in this case. Now, you always want to check it out. But in this case, the reason why it's giving that message is because I had another disk on the original computer that was the system disk. I didn't bring that over here because I didn't need to. So I just wanted to bring the data over. So I'll click on yes, and everything is going to be okay with this. In just a few moments here, we'll see that we will bring in the simple disk as well as all members of the RAID 5 array, at which point it will sync everything up and we'll be back in business. And here it all is. So there's our corp. We have a disk over there with a volume name of corp data. That was our simple volume. We also have some apparently media stream data, which is very good kind of data to put on a RAID 5 disk. And the reason for that would be because of its heavy emphasis on read-only data. So in any case, at this point, we're pretty much done. If we want to just leave the disks here, they'll be just fine on this server. On the other hand, if DC Nugget 4 comes back up again, we can transport them back over there. Now also, since they were originally created on DC Nugget 4, it still recognizes the MBR partition, all the unique identifying information about each one of these volumes that have been initialized initially by DC Nugget 4. So we would not have to import them as foreign disks again over there. Now, one other note here real quick as well. Plug and Play may not initially recognize these disks the way that you would expect it to. Most of the time it will, but if it doesn't, and you know you put the disk in there, everything's connected, the power's on, everything's connected on the SCSI controller, all that, and they're terminated properly, then they're still not getting a detection here. You don't see them in there. Go to Disk Management and right-click and then choose Rescan Disks, and it will double check to see if there's any change in the disk configuration, at which point it should be able to pick them up. Also, if it can't seem to do it from there, you can also go back to Device Manager, and we'll be covering Device Manager more later on in this same series. But then I would simply go to the server up here, right-click, and scan for hardware changes, and it should be able to pick them up at that point especially. If it doesn't do it after that, something else is probably wrong. Now, one of the things you'll want to check for periodically as you go to computer management is you'll see sometimes the disk volume that will say at risk. That means that there probably has been a logging of a high number of I/O errors on that disk, and Windows will kind of try to predict that. It anticipates that disk failing somewhere in the near future. So if it's at risk, you'll want to go ahead and replace that disk. Another thing you can do, however, is to use check disk. Now, that can be done a number of different ways. You can go ahead and use the Start menu to go to My Computer, and then once you get to My Computer, you can either click that, or you can right-click and choose Explore. Either one works just fine. I'll just click My Computer. And then you can go to one of these volumes, right-click on it, and choose Properties. And this will allow you to use various tools. Here at the first General tab, by the way, just get some self-explanatory information about how much space is available and what kind of capacity there is here and so forth. And then you can also compress the drive to save disk space. Very seldomly do we recommend that. What will happen with that is it uses a compression algorithm to just about give you twice the storage that you would normally have, but it also requires processor utilization. And so on servers, that's usually not recommended. There's also an indexing service that will allow you to increase the speed at which you can search for files and search for files on that disk. We'll also go to a disk cleanup item here, which you'll see. We don't really address that a lot, but that will do things like delete temporary files or compress files that you don't use very often. In our case, we're really looking for tools because I want to look at this error checking option that we see here. And with that, we can simply click Check Now, and it will allow you to choose options here to automatically fix file system errors. This would be something like lost chains, for example. Normally, a file is stored in one or more clusters, and most files will be multiple clusters. One cluster will then have a pointer to the next cluster, and that next cluster will then have a pointer to its next cluster. So it chains them, if you will. If there's a cluster in there that's lost and it's pointing to a cluster that doesn't actually exist, or that doesn't actually belong to this file, then that would be a lost chain, and you can fix those kinds of things with this automatically fix file system errors. More than likely, it will not recover all of the data in that file, but it may be able to recover enough of the file so that you can make some decipherable sense out of it. You can also scan for and attempt recovery of bad sectors. This is extremely time intensive because it looks at every sector on that disk to see whether or not it's bad. If it does find a bad sector that's defective or is otherwise unuseful anymore, then it will mark it as a bad sector and it will never allow any data to go in that bad sector again. Also, it attempts to do what's called hot patching, and if there is data in that bad sector that it can recover, it will attempt to, but frankly, the truth is, it hardly ever is able to do that. If it's a bad sector, usually the data that was in that sector is bad right along with it. So anyway, we'll just do the fast way here. Automatically fix file system errors, click Start. It checks the disk out, disk check complete, doesn't show us any errors, otherwise we'd see errors right there, and everything seems to be fine. Now there's also a command line version of that error checking tool, and you can simply click on Start. You can use the command prompt that appears up here, or if it's missing from there, you can go to All Programs, Accessories, and Command Prompt here. Once you click on that, you can then run check disk, chkdsk, and if you're used to DOS, this is the same kind of DOS utility that we've used in the past, at least the typing of the command is the same. And you can type check disk and then followed by a drive letter that you're interested in, let's just say drive C in this case, and press enter. And what will happen here is it checks the disk to see if there are any errors on it. It will not be able to do any repairs or fix any errors on it, in this case because it's the system disk, and there are certain files that are locked open. So it's going to do this in read-only mode. Also, if I wanted to do fixes, I would also use a /F parameter at the end of check disk, and it would only be able to do that for something that was not the system disk, for example. And at that point, it will be able to fix any errors that it found. On the system disk, if you run it with the /F parameter, it will give you a prompt saying, do you want to run a full check disk at the next startup? So you'll have to restart the computer for it to be able to fix any errors. And at the end of the check disk here, it's a little bit more useful because it gives you more information than the GUI, the graphical user interface version of the same tool, because it tells you if there are any bad sectors, it tells you about the indexes, it tells you about all the allocation units. There's 4K allocation units or 4 kilobyte clusters as we have here. It just gives you generally more useful information. Now I also want to show you down here we have this defragmentation option. Well, what is defragmentation? The files on your hard drive fragment. That means they get broken up into pieces. And to understand how that affects performance, go ahead and take out this month's electric bill. Okay, got it out? Great. Now, tear it up into about 100 pieces, scatter it across your desk, and then try to read it. Well, you see, what you'll have to do is try to reassemble that thing like a jigsaw puzzle, and then try to make any decipherable sense out of it. Now, what was faster, reading it while it was in a single sheet, or trying to reassemble it from about 100 different pieces? And by the way, if you took my advice literally and you can't read your bill and you don't pay the bill this month, just tell your electric company that your bill was fragmented. I'm sure they'll understand. Okay, anyway, that's what happens with your files as well on the hard drive, because as the size of those files will expand and contract in size, it has to find free space to put the remnants of that file, and it has to find a free cluster. Well, that's not always available in a contiguous form on the hard drive, so it has to put it in various other miscellaneous locations, and then to read that file takes quite a while sometimes to recover all the data. So with defragmentation, which was new in Windows 2000 actually, and which is actually on license from a company called Executive Software, which also makes a third-party product called DiskKeeper, which is a more full-fledged version of a disk defragmenter. You can use this product to defragment now, and this is free with Windows Server 2003 as well. And all I have to do here is to select a volume, click Analyze. It works with any file system, NTFS, FAT32, FAT, and you just click Analyze, and it will tell you whether or not you need to defragment the volume. In this case, it says I don't need to, and I can look at the report to see how much free space I have, for example, and the size of the clusters I have and all that. The free space is one thing you do want to look at, because unless you have at least 15% free space, it's difficult for defragmentation to optimize the fragmentation or the defragmentation runs. Also tells you which files are the most fragmented here, which might be useful if you have a specific file that seems to be opening slower and slower over time. Now it says I don't need to defragment. If I need to, if I want to anyway, I can click defragment. It doesn't hurt anything. Just click defragment and off we go. And it takes a few minutes, and at the time that it's finished, your disk should read data faster and write data faster. By the way, let's also take a look at the legend that we have here. You'll see the blue information is contiguous files, red information here in the legend here is fragmented files, and what it's attempting to do is to defragment those red fragmented files so we'll have a lot less. One other thing that this defragmenter does not do is that it does not defragment the master file table or the MFT, which can contain some small files and which has, it's the equivalent of the FAT on a FAT volume, and it has information about all the files on your disk. And the other thing it doesn't do is it doesn't defragment the swap file or the paging file, which is a substitute of memory on the hard disk. And that file can get fragmented quite fast and easily. Again, for that kind of optimization, you'll need to get something like Executive Software's Disk Keeper. Now here I've gone to a command line, again because I want to show you another command that you can run from this, and this is the convert command, which you've been familiar with if you used Windows NT 4 or Windows 2000, and this allows you to convert with a /fs for file system to the NTFS file system. And what you also do with this is you have to put in there which volume you want to convert. I don't really have any, but let's say, my drive F was a FAT or FAT32 volume. Well, that would allow me to convert drive F to the NTFS file system. And so you'll simply want to be aware of the convert command. Also, again, if it's the system volume, then it doesn't allow you to do that until you reboot the computer. Now then, returning to the command prompt here, I'm going to show you another command that you can use, fsutil. And this is a command line utility that allows you to manage the volumes and do various things such as set the disks up for a check disk at the next reboot, or to manage quotas and things like this. I'll address quotas a little bit later on in the same section. However, just for your information, a quota is the ability to limit the amount of disk space that each individual user can use on a disk, and it's especially useful if you have multiple users using the same computer so that one user doesn't dominate all the disk space. Now, the quota management does have a GUI interface, or graphical user interface, and I'll show you how to do that later on in this same segment. However, you can do it from a command line as well, which can be useful because you can put this in a logon or a startup script, and that way you can have it apply to multiple machines at once instead of having to visit individual machines. Let me also show you another thing you can do. We talked earlier about check disk. Well, you can use fsutil to do fsutil dirty set. And what that does is it sets a volume, in this case we'll just say C. Well, it sets that volume with a dirty bit. Anytime the operating system boots up and it sees a dirty bit set on a particular volume here, then it will say, oh, I guess I better do check disk with the F option. And so you do that and press enter, and it will mark that volume as dirty. That can also be useful, again, in a script, especially if you've had a virus that has moved through part of your organization, and you want to check the hard drives on an entire section within your organization by running check disk. Well, instead of having to go to each machine manually, you can use this in a script, and it'll be much faster. Now then, returning to the command prompt here on DC Nugget 3, I'm going to show you another utility that I like an awful lot. This is called disk part, and this has a broad variety of functions that you can use with it. To start with, it can do things like list disk partition and volume information, which is very useful for reporting. It can create a simple volume. It can assign a drive letter. It can extend simple volumes, create spanned volumes or delete spanned volumes. It can create a volume mount point, create a striped volume, create a mirrored volume, break a mirror, remove a mirror, create a RAID 5 stripe, or it can perform conversion between basic and dynamic disks. So you see that it does pretty much the whole gamut of disk management. It's a very useful utility for that. Now, with disk part, for example, let's go ahead and just run that. I'll press enter, and it takes you to a disk part command line. Now, once I'm here, let's say that I want to go ahead and select a volume. You'll need to select a disk or a volume so the disk part knows which disk or volume you want to manage. So I'll first of all select volume, and I'll do volume E, which we see in computer management down here under disk management, is the corp data volume. That's a gigabyte volume. So I'll select that. It's also known as volume 0. I could have chosen volume 0 as well in that command line, and we see that right here, volume 0. Then what I want to do is, let's say I want to add mirroring to that simple volume, so I'll say add, and then I'll select disk 2. And that's really all there is to it. You don't really type the word mirror, but it just knows that it will do that by typing in add. And we'll see in the background here, it'll add a volume, or legend for mirroring in just a moment here. There it goes. And now we see that it's resyncing these two, and it did this from the command line without me having to touch the GUI. Again, this could be useful for something like scripting, where you want to do this across a number of servers or even workstations as well. So now that we've added that, let's say that we later on decide, oh, we didn't want to do that. All I'd have to do now is to break disk2. And if I leave it right like that and press enter right now, it breaks the mirror like we did earlier through the GUI, so that the data will remain on both volumes and yet they'll both get a different drive letter now. Or I can do no keep at the end, which will remove the mirror completely from disk2, and you see that that has already happened here. Now earlier I alluded to quotas, and again, that's where you can limit the amount of disk space a user can use on a given volume. So I want to do it on, let's say, volume E here. I want to make sure that each user has only 100 megabytes. Well, the way to do that is to right-click on this volume, and I can also do the same thing from within my computer or Windows Explorer, and I'll go to its properties of the volume and go to the quota tab. Once here I can enable quota management, and at this point all it would do is track how much disk space each user used, and I could check that by going to quota entries, which at this point will only show me the quota usage for the administrators group at this point. As we have additional users connected to and use hard drive space here, their names will also appear down here. In any case, I can enable this quota management. And then if I set a limit on disk space, I can also deny disk space to anybody that exceeds their quota limit. So, depends on how harsh you want to be, I guess. In our case, we're kind of cynical, mean administrators, so we'll be harsh. Anyway, we can do not limit disk usage at all if we like, or we can limit disk space too, and then specify a number. Let's just say, like I said before, 100 megabytes. Notice you can go to kilobytes, megabytes, gigabytes, terabytes, petabytes, or exabytes. Geez, 100 exabytes, you could probably store the whole internet on that much space. Anyway, so we'll stay with 100 megabytes here, and then we'll also set a warning level at, let's say, 90 megabytes. And that's useful because that gives them an advance warning saying, hey, you better delete some files or else you're going to run out of hard drive space. Now also, any users that have mapped network drives to this drive E, to a particular share, for example, on drive E, when they look at the properties for that volume, for that share, they only see 100 megabytes of space available. They don't see this 1 gigabyte worth of space back here. So it only reports that much to them. The quota management tracks the ownership of specific files and folders, and that's how it keeps track of who has how many files and how much space they're using on a given volume. We can also log events when a user exceeds their quota limit or when they exceed their warning level, and that might not be a bad idea to set either. Let's also look at the quota entries here, and here again we see that the administrators have no limit. In fact, if I double click on that and try to limit their disk space, it doesn't even allow me to do so. So there's not much use even in messing with that. You could set a warning level, but it doesn't have much sense. Then I can set up a new quota entry here if I want as well, and this would be my exceptions list. This would be for people that I want to have less than 100 megabytes disk space utilization or more than 100 megabytes. In other words, anybody that's outside of the normal quota that I've already set up. I can do that by clicking Quota, New Quota Entry, or by clicking the little white square that you see in the background there. And you see that I can select of the object types only users. I cannot select groups. There's no option for groups, and that's kind of a bummer, really, because I'd rather be able to set this up by groups so that everybody in the accounting group gets 50 megabytes, everyone in graphic arts gets 100 megabytes, and so forth. Because that might be easier to configure than individual users at a time. Now, I have a user 01 account, and if I want to make sure that I actually have that account and I've typed it in properly, I can click Check Names, and it resolves it for me by giving me what's called a user principal name, which looks like an email address, and which we'll address later on when we talk more about user accounts, and it underlines it. So it's resolved it, tells me that that's a legitimate account. You don't have to click Check Names. I just wanted to double check to make sure it was good. I click OK now, and then I can limit the disk space usage. Let's say rather than 100 megabytes, we want them to have 200 megabytes instead, and we would just set up that exception and give them a 190 megabyte warning level and click OK. And now we see that this particular user has a different setting than my default user. They have 200 megabyte quota limit and a warning at 190. Now let's say you've gone ahead and put a lot of work into this and you add in, a couple dozen more users. And then your boss looks at this and says, oh yeah, that's outstanding, great job. Now James, go ahead and put that on server X, Y, and Z as well. Oh great, I know what I'm going to be doing all day tomorrow now. Well, no, you don't really have to worry about that bad because it's pretty easy if you click on Quota and then just simply click Export. Then you can export it into a name of your choosing. Let's just call it Quota Users, and then I can save that. And then later on, what I can do is to import that into another computer. So if I delete this for now, for example, and then you can even assume with me that I'm on a different computer when I want to import now a list. Then I'll import the quota users that was exported previously, open, and now you see that it has imported that list of users into this computer. And also, if you want to, like I mentioned earlier, you can also use the fsutil command to manage those quotas for you as well. In this nugget, we picked up right where we left off in our last nugget with volume management, and specifically in our last nugget, we converted from basic disk to dynamic disk. This time we converted from dynamic disk back to basic disk. In order to do that, you have to delete all the volumes first, so it's kind of the slash and burn method of conversion, I guess. And then we looked at how to create volumes. There are 5 different types of volumes you can create with dynamic disks. 3 of them are RAID volumes, but only 2 of them are recoverable or fault tolerant. That would be RAID 1, which is mirroring, and RAID 5, which is disk stripes with parity, disk striping with parity. So we looked at how to recover those volumes, and then we looked at how to move the disks. I mean, sometimes the data is just fine, the volumes are fine, but the computer itself has got a problem, so you need to move them into another server. And we showed you how to import those foreign disks, as well as how to work with various disk utilities, such as check disk, which you've probably been working with for years, but other ones which are newer, such as disk defragmenter, and several command line utilities, which can be very useful. Then we looked at how to work with disk quotas so you can limit the amount of disk space that your users have available on a given volume. I hope this has been informative for you, and I'd like to thank you for viewing.